Hi AP Chemistry students. We're going to take a look at a problem tonight. I'm just going to work a problem for you. We're not covering new content. This is similar to what we talked about yesterday, and this is going to be related to some problems that you're going to work for homework tonight. So the homework tonight will not just be um, a lecture. You'll actually have some problems out of the white book to take care of as well. So let's take a look at this problem here. We have magnesium solid reacting with oxygen gas diatomic, and it's producing two magnesium oxides. Typically when we have a solid reacting with a gas, you're going to form a solid. They gave us a delta H value of negative 1204 kilojoules, so this is a thermochemical equation. And the very first question is a pretty simple one. Is this reaction exothermic or endothermic? And we could even throw a Y in there. So hopefully you can tell that right up here we have our negative value there, and so with that negative value tells us a huge amount of information. It tells us this is going to be an exothermic reaction. It's going to give off heat because it's negative value. Now I could ask you to rewrite this thing, and if you were to rewrite it with the heat value actually incorporated into the thermochemical equation, we'd write it like this. Or we might even leave this as a positive value here, knowing that when we are dealing with a thermochemical equation, as long as we place it on the right-hand side and the product side, you're going to have a exothermic reaction. It's going to give off heat. Okay. So let's kind of scooch down here a little bit and talk about some calculations that are involved. So it's asking us to calculate the amount of heat transferred when 2.4 grams of magnesium reacts at a constant pressure. Constant pressure just tells us then that this guy is going to be, we can calculate delta H off of that. So we have a known here of 2.4 grams. So we're going to go down here and we're going to go 2.4 grams. This is similar to an example I gave in the lecture yesterday. 2.4 grams of magnesium. And we're actually calculating heat, so the likelihood is that's going to be in kilojoules. So the first thing that we're going to want to do is we want to somehow incorporate up here our negative 1204 kilojoules into this, and so we're going to convert to moles first. So we're going to say 1 mole of magnesium is going to be equal to 24.31 grams of magnesium. That's our molar mass of magnesium. Now, there's a trick in this problem, and this is why I wanted to talk about this problem. The trick in this problem is if we go up here and we look at magnesium here, magnesium is given as 2 moles per 1 mole of oxygen yields 2 moles of magnesium oxide, giving 1204 or negative 1204 kilojoules as our heat released, and that means for every 2 moles of magnesium that react, we do get negative 1204 kilojoules of heat produced, not necessarily every 1 mole, and that's why I'm not putting a 1 there, because from the balanced equation, that's what we're dealing with. We're dealing with an equality that is for every 2 moles of magnesium, you're giving off negative 1204 kilojoules of heat. So that's just something that we need to keep in mind as we're working these types of problems. If I go through and make this calculation, I do come up with an answer of negative 59.4 kilojoules of heat being released, negative indicating once again this is an exothermic reaction. Okay, let's move down to our next one and see what we're asking about here. So it says how many grams of magnesium oxide are produced during an enthalpy change of negative 90.6. Now up here we said we had negative 59, and what caused that was basically 2.4 grams. So we're expecting more than 2.4 grams. So let's run this through, and it's kind of at the opposite of B, even though this should be C here. It's the opposite of what's going on there. So let's start with negative 96.0 kilojoules of heat. And we are dealing with MgO here, which is what's happening. We're just to make sure. So when we look at that, we're not gonna get confused with our coefficients. And so what we're looking at here is negative 96.0 kilojoules, and so we're gonna kind of reverse everything we did before. So we're gonna go, okay, well, for every 1204 kilojoules, we're gonna have 2 MgOs, and I'm using the coefficients from the balanced equation. And so if I could scroll up there real quick, you can see here that our coefficient here is a 2 as well. If we were dealing with the oxygen would be a 1 here on that coefficient. Now, and this is moles, by the way. And so then I'm going to try to get us over to grams, so I'm going to do opposite. I'm going to go, okay, so for every 1 mole of MgO, I have our molar mass of MgO. So I'm kind of working this guy backwards here. Okay, and so I calculated this as, oops, sorry about that. Molar mass of MgO is 1 magnesium plus 1 oxygen. We're getting 40.31 there. So we're going to multiply those all, divide them by negative. So we have a negative on bottom top. So we're going to have actually a positive value here. And I get 6.43 grams of MgO produced given this heat value. Okay, so let's take a look at this next problem here. So we have how many kilojoules of heat absorbed when 7.50 grams of MgO is decomposed into Mg and O2. Now this decomposed right here is giving me an idea of what's going on here. So remember, if we go back to our original balanced equation, we had 2 Mgs plus O2 yields 2 MgO, and we had a delta H value equal to negative 1204 kilojoules. That was our original value. Now it's telling us that MgO here is decomposing into Mg and O2. So essentially what's happening is we're going to use the reverse reaction here of MgO decomposing into Mg plus O2. So our delta H value, if you remember from yesterday, is going to change. Whenever we reverse a reaction, we change the sign. So this is going to be 1204 kilojoules for this reaction, and we're going to use that for our problem here. So let's start off with 7.5 grams of MgO, and what we're basically working this to is we want kilojoules of heat, so we're going to put kilojoules right over here. And so now what we're going to do is, this is real similar to the very first problem we worked, except we're going to be working it with an equation that's backwards, the MgO being decomposed. So we're going to convert to moles first. So I have MgO there. I'm going to use the molar mass down here to convert to moles, and I keep wanting to put 24.31, and that's the mass of Mg. So this is actually, remember to add in that oxygen. Okay, and then looking at this balanced equation, for every 2 moles of MgO, we're going to get positive 1204 kilojoules working. So let's run this through our calculator here and get us an answer. And what I'm looking at is, I'm looking at an answer of 112 kilojoules of heat absorbed. So it would take heat input to get this guy to run backwards. And so that's tonight's lecture. Now for homework tonight, out of the white book, what I'd like you to do is I'd like you to do questions number 5.38 through 5.40. So there's your homework. It's going to be 3 questions, and there's, of course, going to be like a couple parts on each question. Hope you guys have a good evening.